I'm Paul. I'm one of the co-founders of OpenBlock. As Vaughn mentioned, we do incentive modeling, and we currently power around $2 billion in incentives per year. So we've seen a lot of different incentive campaigns across crypto from all sorts of different programs. So today I'll be talking a bit about what we think are the end game of incentive programs, or what we call trust minimized incentive programs. So today in crypto, incentives are roughly on the scale of $10 to $20 billion a year. The classic types of incentives we see are Bitcoin and Ethereum, proof of kind of staking, issuance, and block rewards given to miners. That constitutes at least 10 billion plus. And then at the protocol and ecosystem level, we see a lot of different types of incentives. For instance, Lido gives over $100 million a year in liquidity incentives. Curve has 50% of their token supply allocated to LP rewards, and people are experimenting with all sorts of different incentive programs, which I'll get into. But I want to motivate the problem a bit more and really try to understand how big will incentives get in crypto. And I think to do that, we should really understand what is the goal with Web3 and what type of networks are we looking to bring on-chain. And I think the broader class of networks are moving corporate-owned networks over to user-owned networks. And today, the internet has kind of gotten to the form where a handful of companies are kind of making up a lot of the value and owning a lot of the internet. And one of the main motivations here is that these should all be user-owned networks. And there's a reason that these corporations have gotten so big and why they're such an investable class. They're very sticky, they have amazing moats, they grow really fast. And NFX kind of has this pretty iconic post from 2017 around how 70% of the value in tech is driven by these network effects. And there's a classic examples like social networks like Facebook, with each incremental user making the platform better. And there's kind of lesser known ones like OpenAI, where each user's data and their kind of interactions with the OpenAI models is improving it for the next user. And all of these networks we think should be user owned, and the people contributing their data should be the ones. And how do we describe that ownership in crypto? Well, that's through tokens. So if we take the value of all these corporate-owned networks and we kind of think about user ownership at 50%, that's to the scale of around $7 trillion. So now that we kind of define the potential scale of token incentives in crypto, what mechanisms do we have to allocate these incentives at that scale? So I'll go through a few different types of mechanisms that we've seen. The first is what I consider like immutable mechanisms. They're trustless but rigid. So these are mechanisms that are like baked into immutable smart contracts. The best examples are like Bitcoin and Ethereum. For Ethereum, I'm going to talk specifically around issuance, ETH issuance for staking rewards, because I think it's a really interesting case where even today, it's an active discussion. We have this mechanism in place in the protocol, and it's powering kind of billions of dollars of incentives per year. But there's still so much active debate as markets move around. For instance, when restaking got popular and LRTs became a thing, it really shifted this exogenous yield for ETH stakers, and it changed the market dynamics. And as a result of that, a lot of ETH researchers came together and a bunch of other factors in the market around, should we think about targeting some sort of ratio of staked ETH to circulating supply? And there would be these forum posts, and some researchers would go and run these like complex simulations, and they'll go and like post it on the forum and say, hey, I think like we should have a target of 1/4. And people would kind of ask like, oh, like why should it be 1/4? And I think like Justin Drake goes on Reddit and he's like, because it's a power of 2, it's 1/2 seems a little bit too big, and like 1/8 seems a bit too low, so like 1/4 seems reasonable. And like, who's really like reading all these posts? Who's like understanding these simulations and kind of looking into these like different models? they're pretty rigid, and it's crazy the scale of impact that they have. The next one is kind of governance mechanisms as owning these incentive programs. So some examples of this are like RPGF. Arbitrum has these short and long-term incentive programs, and usually they take the form of a DAO vote, some set of delegates, or a committee that is in charge of running this program. And when you involve people in the mix and you kind of move away from this like data-driven or immutable approach, you start to get like very subjective targets. One of the biggest issues with like the Arbitrum STIP was there was no clear objective. You had dozens and dozens of protocols that are like asking for millions of dollars from these DAOs, and they don't know if they're trying to grow TVL or fees or sustainability. And we did this like whole analysis on how effective was this, and you'd see these crazy metrics like the DAO is spending like $4,000 to acquire a single user, and certain protocols had like a third of the rewards go to like one whale who would just like leave and then dump like right after the program ended. And it would just kind of get to this like obscure place where you have this like one committee with like little optics into like what's happening, and it just wasn't as efficient. So then you also look at what if we like centralize a bit more to like specific providers who are very competent at what they do. And one example of this is like Aave risk management. So if you go to like Aave is constantly updating like risk parameters for different pools based off like market changes, and they have these kind of handful of providers who run simulations that are kind of closed source, and they go and post on the governance forum, and hopefully everyone kind of believes these providers. There's like not as much accountability. People who voted them in kind of just vote yes for a lot of these kind of changes, and this is how a lot of the risk management is done today. So and the most recent one, I'm kind of progressing in the form of like most decentralized to least decentralized, and this is like a very popular phenomenon right now, which is what I consider like social debt mechanisms. And like point systems are a good example of this, where a project will commit to a point system, so some tracking of a user's kind of behavior in the protocol. So it could be their stake over time, in the case of like the eigenlayer point system. And this isn't done on a smart contract, it's done through this kind of off-chain communication. And now the whole community, all the different participants of this network, they will go and like engage with the protocol in like different ways that they think will like maximize their points or maximize their potential airdrop. And this gets pretty funky because people behave in really weird ways, and one of those ways is through sibling these point systems. So like in layer 0, for instance, this guy named Ruslan created a bunch of addresses, and he wasn't very smart about it because he called his addresses Ruslan 002, 003, 004.eth, and it became like a big meme in the layer 0 community, and the CEOs tweeting, "Oh, Ruslan," like. And it was basically this comical thing of like, if you don't have like a clear incentive mechanism, I mean, it can be gamed in all sorts of different forms, and the kind of creators of this mechanism can choose to reward you as they wish. And that can be pretty disastrous too, like once a lot of this like inorganic activity moves away or this mechanism is replaced, there's like sharp downturns in the sustainability of like key metrics like transactions. So those are kind of a few different examples of different types of incentive programs. And I think the commonality of like what's good in across them is that they should be data driven and they should be trust minimized. So if we look at incentives in Web 2, just to kind of get a understanding of the scale of incentives and data that goes into it, in 12 seconds, or the kind of span of an Ethereum block, Uber is consuming around 82 gigabytes of just driver data to model out their entire incentive programs on the driver side. And for scale, Ethereum blocks is roughly around 80 kilobytes. So we're like very much like orders of magnitude off, and even with like rollups, you get to the scale of like a few hundred kilobytes per block. So how can we kind of scale this? There's two things we need to scale. One is like the kind of coordination among these different network participants, and then like the verifiability of like compute, which I'll get into. So one thing we can look at is federated learning, and federated learning, also known as collaborative learning, is a subfield of ML, where it focuses on settings where multiple entities are collaboratively training a model while keeping their own private data. So hospitals are a prime example of this, where each hospital has their own private kind of user data, patient data, and they may run their own local models, and then you can aggregate this in some form to some global federated server. And I'll kind of get into why this is a useful idea, but maybe you can already see some ties into how DAOs and governance can use this architecture. And the second important primitive to getting us towards trust minimized incentives is coprocessors. Broadly is like a pretty new category. And there's two forms of this. There are zero-knowledge coprocessors, and there's cryptoeconomic coprocessors. So in the zero-knowledge case, there's a variety of implementations kind of in production in the past year or so, where users can, some contract on chain can submit some arbitrary computation. It may be some data query of historical Ethereum data, and it's passed to some relay contract. A zero-knowledge proof is generated, and that proof can be verified on chain along with the output of running that query. And this is a really important primitive because it supercharges protocols. It kind of gets past that scalability problem because it allows smart contracts to access like really interesting data and arbitrary computation that allows it to be much smarter about things like incentives. So what could this look like in practice? This is kind of like a outline of a recipe. If we have like a decentralized exchange, for instance, we can create an objective function as a DAO, and this objective function may be something like maximizing trading fees with some other measure of efficiency of liquidity, and then you subtract out like the cost of this liquidity and the cost of, let's say, Sybil or wash trading activity. Then maybe you're subject to some set of constraints like the total incentive budget. And then you can have a variety of different providers, anyone in the DAO who is training models, and they're providing these recommendations that maximize this objective function. And then importantly, providers can verify their data, they can verify their models and their inference through that ZK or cryptoeconomic coprocessing technology. And then DAO members can come together, they can look at the output of these models, they can evaluate what was the best, and they can update their economic policy, or even run like smaller experimentations on like subsets of users within the protocol. And that kind of wraps up into this architecture that I call proof of impact, where you have these like various providers. They all have their local data. They can all commit to proofs that this data wasn't poisoned or that it was accessed from on-chain data through like a ZK proof. They may all commit various amounts of stake that can be slashed if any of these proofs are invalid. And then it comes down to community model testing, consensus, and then aggregation. So yeah, we're pretty excited. We feel like the basic building blocks of these of this architecture are kind of in production today, so it's not really too far-fetched in theory, and we're already seeing signs of this like in practice in DAOs, and this is kind of where we see the future of trust minimized incentives to be. Well, thank you so much. Any questions?
Yeah, so it seems like you can train the larger model by simply having the weights of the local models and submitting those without the actual data. Is that the right way to interpret it?
Yeah, you can. There's a few different ways to go at it. Like you can have that one, like let's say DAO-owned larger model, that's certainly one approach that the DAO could maintain, or you could just have like individual models that are like kind of committed to, and people are like making attestations about them, and then the best model out of all of those is kind of rewarded the most.
Okay, so you're more just selecting, like in this diagram, you'd be selecting one of the three local models rather than aggregating all three of them into a larger model.
Yeah. So in this architecture, there would be one large model, like the model architecture, but you could replace model architecture with like objective function or some utility function, and then whoever is like maximizing that, they're chosen as like the winner. So there's kind of ways to like adjust this architecture a bit, but like both work.
Do you lose the value of having all the aggregated data train one model?
Yeah, there's definitely benefits of that on kind of improving accuracy. So if a lot of people are collecting data from different sources, so in the case of like a hospital example where everyone maybe has their own private data, and if they all came together, they would have like a smarter model. Or another example, like fraud detection. So you can imagine like every credit card provider has their own data sets on like their user fraud behaviors, and if they all like were able to cooperate, then they could create one model that's like everyone uses, that's like much smarter. So cases where like more data across all different providers increases accuracy is where you'd want to use that aggregated approach.
Got it.
Thank you. Are you expecting the proofs of impact to be available for everyone to see, or do you see a future in which these proofs, like the data, is actually guarded, and then you'd need something like Ezekiel for people to be like, okay, this is the result of the model, and this is what we're rewarding?
Yeah, I think that's a great question. So in this architecture, you can really choose what you want to make private or public. So we could imagine that a lot of providers would want to keep their data and models private, and then they could use exactly things like Ezekiel, where you're taking like right out of the box whatever like PyTorch model you built in this like Onyx file, and then converting it into a circuit, and then just creating your proof, and that's sufficient to prove that you used legitimate data that came from like on-chain sources and it wasn't poisoned and things like that, without actually revealing your data. So I'd imagine that to be the case.
And then, for example, how would you be thinking of the rewarding of these two different components, right? Because you've got the data provision on one side, and then the generation of the model, which is capable of aggregating or like analyzing that data in such a way that a reward for like this proofs of impact is useful.
Yeah, so in the federated learning case, like one way to do this like model aggregation is through like kind of this like weighted average of the model weights, and you can essentially look at, and if you have that one global model, you can look at for the kind of delta of the weights of each individual provider. You can look at the individual provider's contribution to the global update. So if they had a significant part of that update, then they would get proportionally higher rewards. So there would be like an ongoing incentive for this update as well.
Yeah, go.
Thanks. Yeah, I was wondering if you could maybe speak on the costs for like proving the models, because like last time I looked into that, like ZKML and stuff like that was prohibitively expensive. So I wonder if that has maybe changed in the last year, or if that's still the case.
Yeah, I think like I'm not too in the weeds of like the kind of latest proving systems stuff, but in broadly in these use cases, the costs are even if they're higher, they're still very low compared to like how big of a update you're making. For instance, like changing like a risk parameter is a very high value update that like even if it takes like a couple hours to generate this proof for a lot of money, it's kind of sizable. It's decent. And then there's actually like through crypto economico processors, I don't think they've really been put into production yet, but you can maybe sidestep a lot of that. There's even like TEE operators that are like coming to EigenLayer, for instance, where you can still retain privacy, but it's kind of done in that trust environment. And with that, we can't really, it's hard to estimate what the cost would be, but probably be lower and faster than ZK.
Yeah, yeah. Okay, cool.
Thank you, friends. No, I think it's super interesting. Thinking about sort of like data maximized and or whatever, data driven and trust minimized is like for some types of rewards, definitely, right? Like, you know, if it's like TVL over a set period of time and +1 on having like different models that's submitted by the DAO, I think it definitely makes sense. But like retro PGF, you know, sort of was on the example slide of like not working, and it's like, well, because the data wasn't meant to be, you know, the metrics were meant to be the sort of goalposts, and sort of how do you think about like, as the grant space can develop more and we can have more maybe clear lines in the sand of like, you know, ongoing programmatic community decided rewards, and then sort of like surprise, retroactive, fun community, you know, like.
Yeah, definitely. And I think maybe I was a bit harsh with those. I think they're all working well, and I think they just have trade-offs. So as like, we've run like public good funding programs for like Solana, OpenBlock, and one thing that we noticed was it requires a lot of reading time for kind of these badge holders and delegates, and that processing time, because you don't have like clear objectives, requires like tons of different discussion, collaboration, like everyone has their internal objectives, and you have to like, it's very hard to do at scale, and everyone has their own preferences. So in general, for these like, what I was considering like governance-based mechanisms for allocating incentives, they can be a bit sluggish, even though they're definitely open. They have their pros, and maybe that's suitable for some types of kind of less objective forms of evaluating impact.
Yeah,
so.
that's one.
Okay. All right.
Cool.
Was that another?